Okay guys, let's get started with 5-1, postulates and paragraph proofs. This video, we're only going to be talking about postulates and how we can use them. So a postulate / axiom is a statement that is accepted as true without proof. Okay, let's get to know some of the postulates. Okay, here we have some postulates for points, lines, and planes. We have postulate 5-1. Through any 2 points, there is exactly one line. So here I have 2 points, P and R, and I have exactly one line, N, through them. Okay, postulate 5.2. Through any 3 non-collinear points, non-collinear, if you don't know, it's points that all do not lie on the same line. Okay, through any 3 non-collinear points, there is exactly one plane. So here I have 3 non-collinear points, and we have one plane, K. Don't forget you have a copy of all the postulates. I'm just going through them really quickly. Postulate 5.3. A line contains at least 2 points. Okay, at least. That means there has to be at least 2 points. There could be 3, there could be 4. There's a lot of points on a line. So for example, I have P, Q, and R on line N. Postulate 5.4. A plane contains at least 3 non-collinear points. So plane K has to have at least 3 non-collinear points. So in this example, I have 4 of them, L, B, E, C. Postulate 5.5. If 2 points lie in a plane, then the entire line containing those points lies in that plane. So if 2 points are inside of a plane like we have here with A and B, then the entire line that passes through A and B is also in that plane. So the line M is also in plane K. Postulate 5.6. If 2 lines intersect, then their intersection is exactly 1 point. So here I have 2 lines, S and T, and their intersection is at exactly 1 point, and that's at P. Postulate 5.7. If 2 planes intersect, then their intersection is a line. So here I have 2 planes. Here I have F, and here I have G. Where they intersect, that is a line, and this line is W. Now let's go over an example of how we can use postulates. Example: explain how the picture illustrates that each statement is true. Then state the postulate that can be used to show each statement is true. So the first one, line M, here's line M, contains points F, there's F, and G. Point E can also be on line M. Which postulate helps me show that this is true? Okay, so the explanation. The edge of the building is a straight line M, so this is M. Points E, F, and G lie along this edge, so they lie along a line M. So they're on the line. And don't forget about postulate 5.3, which states that a line contains at least 2 points, and this shows that this is true. A line has to have at least 2 points. It could have 3, it could have 4, it can have 1,000. So E can definitely be on line M. Let's go to another example. Okay, we're using the same picture. We've already done A. Let's look at B. Line S and T, here's S, really small line right here, and here's T, intersect at 1 point. Which postulate shows that this statement is true? Okay, so here we have the explanation. The lattice on the window of the building forms intersecting lines. S and T are intersecting lines. Line S and T of this lattice intersect at only one location, point D. Postulate 5.6, which states that if two lines intersect, then their intersection is exactly at one point, shows that this is true. Two lines intersect at exactly one point. So that's why this is true. Let's look at some more examples. Okay? Determine whether each statement is always, sometimes, or never true. First example, if two coplanar lines intersect, then the point of intersection lies in the same plane as the two lines. Now let's go back. Coplanar, that means that they are both on the same plane. So if two coplanar lines intersect, then their point of intersection, the point where they cross, also are on that same plane. So is this always, sometimes, or never true? And which postulate would you use? Okay, hopefully you said always. Postulate 5.5 states that if 2 points lie in a plane, then the entire line containing those points lies in that plane. So since both points lie in the plane, any point on those lines, including their point of intersection, also lies in the plane. Okay, so the point of intersection is part of the line, and so because the entire line has to be in the plane, the point of intersection is also on the plane. So this is always true. Let's look at another example. 4 points are non-collinear, so they all are not on the same line. Is this always, sometimes, or never true? Okay, hopefully you said sometimes. Postulate 5.3 states that a line contains at least 2 points. This means that a line can contain 2 or more points. So 4 points can be non-collinear, like A, E, C, and D. A, E, C, and D are not on the same line, so they're non-collinear. Or they can be collinear, like points A, B, C, and D. Okay, so this is sometimes true. Okay, it's time for you guys to practice. We're still talking about always, never, or sometimes statements. So let's start with the first one. What do you think? Two intersecting lines determine a plane. Is this true, always, never, or sometimes? Hopefully you said always. Between any two intersecting lines, there are always at least 3 non-collinear points, and postulate 5.2 states that through any 3 non-collinear points, there is exactly one plane. Okay? Don't forget, drawing helps. See if you can figure out a way to draw this so that you have a visual, and that will make things a lot easier. Okay, let's move on to the next problem. Or actually, let's move on to your classwork. So for this part, I want the work on a separate sheet of paper, and you're going to determine whether each statement is always, sometimes, or never true. Make sure you explain. Include a visual if you need to, okay? So you have 6 problems. I want this done by the end of the class period, okay?